happen in reality. We will have two practical. First day will be with the quadcopters, and the second day we will use the airplanes. Fixed wing. I'm not sure what is your schedule. Maybe you will go only tomorrow for a quadcopter demonstration. If someone have a desire, in Sunday we will make the second day of our practical work with the airplanes. Okay, I will now show you the systems of the drones because I have not much time. Okay, the minute. Okay. This is applications of the drone systems. Mr. Fillipov is from Geology and Geography faculty of Sofia University, and they are specialized in satellite images, airplane images, map making, technology for processing of such images. And this is the reason because he is involved in this project, and he is the driving force for this innovation. Okay, this is the some hot topics for previous and for this year too. This is challenging new technology, and one of these challenging technologies is a drone. Almost everything is tried to be done from drones. Postage parcels, military applications, advertising, sports, cartography and so on. There is too many applications. I cannot list all these applications. Okay, it is very important if you want to use the drone to know what is advantages and limitations of such systems. It is very important because if you have no idea about this, you may buy expensive equipment, but you can do nothing. This is very, very important part of the unit. Okay, first advantages. Drone is almost ready to use. You can just put the drone in your car, drive to the place where you want to use it, and you just use the drone. This is in comparison with the big airplanes or satellites. There is no comparison. If you want to use a big airplane, you may need maybe days or many hours to order the airplane, to wait for a flight plan and to some permissions from air control. For satellite, it is day or months if you have to purchase some pictures on some region and wait when satellite pass through this region and you have the real pictures. The drone is very express too. Second one, because drone fly very low altitudes compared to big airplanes and satellites. Here we speak about meters, or 10 meters, or 100 meters. The regular airplanes fly, for example, 100, 200 meters. Satellite is 1,000 kilometers. The distance is very important when you take pictures. When you are near to ground, you have very, very high resolution of the pictures. It's almost impossible to obtain pictures with such a resolution from satellite. one of the best modern satellites in the world have a pixel resolution about 50-60 centimeters. They're even lower, about 30 centimeters, but it is almost impossible to have a good pictures with this resolution. For drones, you can take the pictures with millimeter resolution. And the last important advantage of the drone is the real time. For example, if you have some disaster or some event that is important, you can use the drone just at this time. With airplane or satellite it is difficult. With satellite it is almost impossible to order the satellite for just this event, because they have fixed orbit and it is very expensive to change the orbit. For big airplane it is very expensive and very difficult to coordinate the time of the event with the time of the flight. This is the main advantages of the drones. Now, main limitations. In the next slide, I will show you the classification of the drone, and you will see that there is a very broad range of drones. High altitude, low altitude, high duration, low duration, but the main part of the drones that is used are quadcopters. This is the most popular. Almost every smart person or universities have some kind of a drones in their own. And I will give you the limitations for the drones mainly. The first one is short flying time. The standard flying time for a quadcopter is, for example, 15-20 minutes. It's a good time. It is not very long. The second is linked with first limitation. It is a limited observation territory, because for a 20 minutes you cannot fly very far away. And the third is a limited payload capability. Of course, there is a huge drone that can handle tens or thousands kilograms, but it is not the mass drones. The mass drones can handle grams or kilograms. This is the most popular. If you have a very special type of equipment, these limitations are not true. But for most popular application, this is the limitations. And from these limitations depend the kind of task that you can do, that is preferred for drones and which are preferred for airplanes or satellites. Okay, here is some brief classification. This is based on the altitude and flight time. The second is about the construction. If the drone is fixed wing, it is a rotorcraft like helicopter or multi-rotor like quadcopter. There is a drones, of course, like balloons that are very useful in some situations too. Okay, for high altitude long endurance, the most appropriate and maybe the only is the fixed wing glider type high efficiency airplane. The main missions are military, border control, scientific. Medium altitude long endurance. Yeah. It is occupied by the fixed wing too. The tasks are almost the same. And the medium altitude and medium endurance, in addition to the fixed wing, you can use helicopter type drones with the gas engine, because they have a longer flight time than electric powers. When you go in the low altitudes and short endurance time, there is a place for electric powered drones like electric helicopters, electric multicopters. The applications is very broad range: commercial, advertising, sport, hobby, scientific, agriculture. There is no time to mention all of this. Okay. If you not use the drone for advertising or for sports, the main application of the drones are photogrammetric. It is the taking pictures of the ground and making some processing of these images. This can be used in cartography, on agriculture. I'll show you some slides what can do with this data. Multi-channel mapping, it is more advanced application than just the visual camera. This is mainly used in scientific and agriculture. The last year technology is generation of digital elevation models from 2D pictures. You have 2D pictures, but with a modern software technique and some metrics, you can generate 3D model of the terrain. This is very interesting. I will show you some of our results for this technology. The most convenient is video recording, different type of sensors, for example, gas analysis, radioactivity analysis, magnetometers. This is for scanning some region for some physical parameters. And the most broadly used is advertising, sport and hobby. Okay. Why you prefer to use drones for in this scenario for some disaster monitoring in this example? You have several advantages. For example, you have forest fire. The classical approach is to use satellites. There is a number of satellites in orbit that monitoring forests for forest fires, and they warn the firefighting forces to take any measures. But this is very good, but if you have the quotes from satellites, you are not able to see the forest. It is interesting that almost maybe 2/3 from the time when satellites fly over this region, they have a quotes and bad visibility. It is rare to have a good visibility and satellite to take good pictures at every pass. This is the reason why we prefer to use drones for such applications. Of course, because it is very mobile. Drone may be used almost everywhere. If you have cloud, the drone can fly under the clouds and can take the pictures of the forest fires in this case. Okay, and this is the real scenario. We have such a scientific project to have the to photograph this archaeological reservoir. This is near the city of Burgas. This is from the Rome early ages. And there is a very interesting archaeology in this location. We have a scientific project to map from air the region, to prepare orthophoto map, to prepare digital elevation model of this site, and to make some advanced multispectral images to find underground facilities that are not visual, that cannot be seen when you walk on the ground. It is very interesting technology. I'll see what results we obtain from this project. Okay, how we do this? The first one, when you prepare for flight, is to establish a network of ground control points. This is very important because this gives you the metric of the distances on the ground. If you just take the pictures, you are never know what is the real distance on the picture in meters. When you establish the network of the ground control points, you have the exact coordinate of every point. You know the exact distance between these points, and you can do the metric of the image. This is the image that you can measure every distance on the map when you have metric. This white paths are our ground control points. This is the places where we place these points. It is some tricky how to choose the best point for a ground control point, but it requires a lot of experience. In this project, we choose to set, I think, 5 ground control points at some specific places that will be important when we do the metric of the whole image. And this is the precise GPS coordinate of every point. Okay, the second task is to prepare point 1. It means to decide what we want to map. For example, this region is interested for us. We must to choose the region, the altitude of the flight, the speed of the flight, the runway from which we will start flight, and the places where we will finish the flight. After that, this is our region. After that, using the special software, we prepare the flight form. This is the track where the plane will fly. The plane flies this way. And it captures every part of the underground region. The importance here is to have a very good oversampling. When you prepare such kind of images, it is not necessary to have 2 pictures, one just near to the next. You must oversample the picture if you want to have a good result. Okay, and here you can see some of our pictures that is taken with the airplane. This is the tallest building in the Sofia. This is golf course. This is the archaeological place. And this is the final result as orthophoto map. It is made from 157 pictures that are correctly projected, auto-rectificated, and stitched to form the whole batch. Okay, this is the second task, as I mentioned. This is taking the pictures in two spectral bands. The first one is color picture red, green, blue with three spectral bands. The second one is infrared. It is very interesting technology. This is used mainly from satellite, but now we use this with the drones. The big scientific satellites have such kind of equipment. They do the multi-channel mapping of the Earth in different spectral bands, and you can extract a very useful information from such kind of pictures. Okay, this is the result. This is composition map. This is produced with processing and combining the different images from different spectral bands. This is the result. If you see the result, it is not very clear what just you can see, but it is very informative. I can show you what we see when you use this technique. Okay. This is one of the place that is with a clear grass. When you walk on the ground, you see only grass. But what you can see if you use this technology. If you see, it is very small. Okay. Oh. You can see the circles. This is underground facilities. This is based on the technology that if you have, for example, the wall underground, the content of the water on the ground above the wall is lower, and the color of the grass is different. The difference is so small that with eyes you cannot capture this difference. But when you use this technology, you can see the difference. This is very interesting technology for covering underground facility. Using similar technology in Egypt, archaeologists from Italy, I think, find the whole ancient city in the sand dusts. When you walk over the ground, you can see nothing, but when you see with this technology, the basement of the houses and the walls are clearly visible. They use satellite images for this because they find the whole town and the object is big, and you can see this from satellite. We use drones here because our object is smaller. I think that there is some wall, ancient wall, and maybe this year archaeologists will try to discover this wall. Okay. And this is the last task from the project. This is 3D generation. How from the 2D pictures you can generate 3D model of the terrain. This is the relatively new technology. This is Italian innovation. There is several softwares that can do this using this technology. It is based on generating of the cloud of points from all pictures, and finds the projection of all points from different pictures. It is not so easy to be explained. I can show you this slide by slide, but it is a longer time, and I can now show only the final result. This is very computer-intensive operation and takes a very long time. It may take 1, 2, 3 days on very powerful computer because the amount of information is very huge. For example, you process some gigabytes of pictures to obtain this model. but it is very high efficiency and very precise results. This is a result of the terrain that we generate from these pictures, and this is cover model. Red is high, green is low, and this is some 3D visualization. In Monday we will go to 3D laboratory in mathematical faculty. They have a good special 3D projector that you can see this image. And this is a classical video surveillance. It is for military, for special operation, for disasters. This is a conventional application of drones. Okay, there is a lot of things, but I think that I have not enough time at the moment.